Today, we're going to be looking at patterns in algebra and looking at simple matchstick patterns. What we're going to do is come up with an algebraic rule, but really understand where the rule comes from. We're going to look at one that is really popular in schools. We're going to come up with 3 generic questions that you are asked in school a lot with patterns. So we're going to look at this linear pattern where it has 1 block and 4 sticks, and then 2 blocks with 7 sticks, and 3 blocks with 10 sticks. So what we're going to do with these blocks is we're going to figure out how many sticks are in the next diagram, how many sticks are in the 10th diagram, how many sticks are in the 20th diagram, and then we're going to write an algebraic sentence that describes the sentence, or that describes the system. But we're going to work a little backwards. We're going to start with an algebraic sentence to describe this system and then go back to our first question. So I've already drawn out our blocks and written the number of squares with the number of matches. So let's count them to make sure. Let's look at our first square. Let's count the sticks. 1, 2, 3, 4. 4 sticks, or matches. Okay, let's look at 2 squares. 1, 2, 3, 4, 5, 6, 7. 7. 3 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So by looking at this, we can easily tell that they are adding 3 each time. So we can easily look to see if we added on another square, how many matches there would be. 13. So in order to find the 10th square, we can go plus 3, plus 3, plus 3, all the way to 10, or we can come up with an easier equation to help us so where we don't have to add plus 3 each time, or we can easily just draw in extra sticks, but that would take a really long time. So let's look at a different way that we can write 4, which is 3 plus 1. Another way we can write 7 is 3 plus 3 plus 1. And another way to write 10 is 3 plus 3 plus 3 plus 1. So looking at the first square, and if there are 4 matches, we can tell that there's one group of 3 plus 1. Looking at 2 squares, we can tell that there are 2 groups of 3 plus 1. And looking at the 3 squares, we can tell that there are 3 groups of 3 plus 1, which essentially is the same as multiplication. So we can write 3 times 1 plus 1, 3 times 2 plus 1, and 3 times, what's a plus sign? 3 times 3 plus 1. So looking back at our questions, we know that the written sentence, or the written algebraic sentence for this would be m equals 3s plus 1. The m standing for matches and the s standing for squares. So let's look at our table. So we know that 1 square has 4 matches, 2 squares 7, 3 squares 10, then 4 squares. So if we take m equals 3, 4 plus 1, we know the answer is 13. So let's write 13 here. And exactly right here. M equals 3, that's a 10th. M equals 3, 4 plus 1, which is 13. Now let's look at how many are in the 10th spot. So we know that if we do m equals 3, 10 plus 1, our answer is going to be 31. Right here, m equals 3 times 10 plus 1 equals 31. Now looking at our 20th, m equals 320 plus 1 equals 61. Did I write it right? 61. So, from looking at this, we already stated that our algebraic sentence for the system is m, which is matches, equals 3 times the number of squares plus 1. I don't know what else to say. Today we're going to demonstrate and explain the process of uncovering problem structures and representing relationships between quantities using strip diagrams. We're going to look at two different types of problems. We're going to look at a part-part whole, which involves two parts that are conceptually or mentally combined into one collection or whole. These kinds of problems often conceptually combine different kinds of objects. We're also going to look at a compare problem. Comparisons involve comparing two quantities. The third quantity in these problems does not exist, but is a difference between the two amounts. So first, we're going to look at William and Sally put 160 marbles into a jar. William puts in 83 marbles. How many marbles does Sally put in? By looking at this, we know that this is a part-part whole question. We know that the whole is 160 and part of it is 83. So we're going to look at our part-part whole chart. We know that part is 83 and the whole is 160, and we need to find the other part. So, looking at this, we know we can make a problem. 160 minus 83 gives us our answer. So we can make a strip diagram where this equals 160, and we know part of it is 83, and we need to figure out the other part. So we know 160 minus 83 equals 77. So we know the second part to this part-part whole is 77. So now we can fill it out on our part-part whole. In order to figure out if we got this correctly, let's check our math. 83 plus 77. 7 plus 3 is 10. 8 plus 1 plus 7 is 16. So we know our answer is correct. Now let's look at another problem. Jonah has 10 pennies. Kennedy has 7 pennies. How many more pennies does Jonah have than Kennedy? Looking at this problem, we know that it is a comparison problem. So in this, we know our large set, which is what Kennedy has, is 10. And then our small set is we know our large set is what Jonah has, which is 10. And our small set, which is what Kennedy has, which is 7. And we need to figure out what the difference is. So, let's take our board. Let's draw our strips. So this is our large. and this is our small. So we know our large set, which is what Jonah has, is 10, and our small set, which is what Kennedy has, is 7, and we need to figure out what our difference is. So we can look at this, and we know that 10 minus 7 is what the problem is we're looking for. So 10 minus 7 is 3. So we know that the difference between what Kennedy and Jonah has is 3 pennies. We can also draw this sideways like our other strips to look at it a different way. So this is Jonah's pennies, which is 10. And this is Kennedy's pennies, which is 7. And this is what our difference is, which is what we were trying to figure out. And we know that the difference between Jonah and Kennedy's pennies were 3. So, after this lesson, y'all now know what the difference is between a comparison problem and a part-part whole. Y'all learned how to do it not only through the diagrams that we gave y'all, but y'all also learned how to do them through strip diagrams.